What we are going to do in this video is talk a little bit about lipids. Now, a lot of times lipids are strongly associated with fats. And that's not incorrect. Fats are lipids, but not all lipids are fats. A better definition or a better association for lipids would be a class of molecules that you often see in biological systems that are not so water soluble. And I didn't say outright hydrophobic, which means not attracted to water, because there are definitely lipids that have parts that are hydrophobic, that are trying to get away from the water, but there's other parts that are hydrophilic, that like the water, that would be attracted to water molecules. Now, in terms of roles they play in the body, and we can think of fat molecules here, well, they definitely play a role in terms of energy storage. Whenever I look at my belly, I just like to think of all that energy that is there covering my six-pack. They could be involved in signaling. In future videos, we're going to study hormones, and hormones are nothing but molecules that help transmit a signal from one part of the body to another part of the body, and many of these hormones are lipids. They're also involved in membranes. So a lot of the time in biology, we're going to talk about cellular membranes and how they're formed with these phospholipids. And we'll see these phospholipids in particular have one end that's trying to get away from the water and another end that is attracted to the water. And that's actually what makes them good for membranes. Just going back to fats, let's actually take a look at what some of these lipid molecules look like. So this right over here is an example of a fat molecule, but the general structure you're going to have is these three fatty acids. So that's one right over there, one fatty acid, two fatty acids, and three fatty acids that are connected to a glycerol. And don't worry too much about the words here. You'll study them more when you get to an organic chemistry class. But that's where this word triglyceride comes from. Tri for your three fatty acids and glyceride from glycerol. And triglyceride is in fact another word for fat. And what makes a triglyceride not so soluble in water? Look at these long hydrocarbon chains where you just essentially have a bunch of carbons and hydrogens. Those parts, remember, things that are soluble in water they tend to be polar molecules, things that have a partial charge on one end or another, or even a full charge. But when we look at these hydrocarbon chains, they tend to not have these partial charges on one side or another, and so that doesn't make them so soluble in water. And another word that you sometimes hear associated with fats, saturated or unsaturated fat, that's really referring to what's going on these hydrocarbon chains. If the carbons are bonded to as many hydrogens as they can, well, then you're talking about a saturated fat. It's saturated with hydrogens. If it's not bounded, in theory it could bond to more hydrogens because it has some double bonds in there, well, then it's unsaturated. And maybe in a future video we'll talk about the health issues of saturated versus unsaturated fat. Sometimes in popular culture, fat gets a bad name because everyone's trying to get their six packs or whatever else. But it's very important to realize that without fat, you would die. Many vitamins, which are not so soluble in water, making them in fact lipids, need fat in order to be absorbed into the body properly. But as I also mentioned, all lipids are not fats. Here are more examples of lipids, and I'm not going to go into detail into their molecular structure, but you see something similar here. They all have long chains of hydrocarbons that aren't so soluble in water. These parts right over here would be hydrophobic. But what's interesting, especially about this sphingomyelin, which is involved in your myelin sheath in the brain, it helps electrically insulate neurons. It's also involved in membranes. It makes up a substantial part of the phospholipids in membranes, is that this sphingomyelin right over here has a part that actually is hydrophilic. And as we'll see later on, that's what makes molecules like this, phospholipids, this is a sphingophospholipid, makes them good for membrane structures because the part that's attracted to the water could be on the outside and the part that's not attracted to the water could be on the inside. And so you can form these membranes that a cross-section of which would look something like this, where the circular parts are the parts that want to be around the water, while these tails right over here, these are the hydrophobic chains that want to go away from the water. And this is, in fact, what cellular membranes actually look like if you were to zoom really, really, really far in. I'll leave you there. Between lipids, carbohydrates, proteins, nucleic acids, we've really covered the major macromolecules that you will see in biological systems. Once again, what makes them macromolecules? Well, they can be composed of many, 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 many atoms. They aren't small molecules.